All right, so this is session 1.2.2. Some things to ponder. Why do we see things, and what do the arrows represent in our consensus model? Obviously, when we do these sorts of lessons, I'm going to be a little bit more direct instruction so that it's a little quicker and go over there. And sorry that these videos have been late. I had a bunch of technical issues this week, which I think I have solved. Here we go. When we are thinking about light or being able to see, we need a light source, we need an object, we need reflection, an eye, and a path. So if a light is turned off and the room is dark, we can't see anything. When the light is turned on, then we can see an object. But why? We see an object because the light travels in a straight line. Now again, it's not just one line of light. Like you can see this all around the light there. Light is emanating in straight lines all around it and like almost at 360 degrees. It hits the object, or not hits. It bounces off the object. It reflects off the object and it kind of travels around. And anybody who has an eye where that reflection is hitting and a clear path will be able to see that object. Okay. If something happens and there's like a block here, like let's say there was a wall there, then you wouldn't be able to see the object because the light would get blocked and then it would probably reflect that way, right? And that way. Okay. Take a moment, write down, what do you remember? Why might it be important? What does it connect to? And I'm going to move on. But so you pause the video, and I'm going to move on. Let's skip that. Remember that one of our jobs is to be looking out in the real world, like a scientist would, about the different phenomena that are like the ones we're looking at. Have you found anything? Send me a photo. Draw a picture. We're thinking about the light. So when that light is on in one room, we have the mirror over here and we have the window over here. So what happens if we switch the light? If we switch the light, what happens? So I want you to take a moment. I want you to think about that. I want you to pause the video and I want you to make a prediction. What happens when we change the light? So I'll tell you what happens. The phenomenon reverses itself. So what do I mean by that? I mean, like with the light on in this room and no light here, then there's the mirror over here and the window here. So you can see if you're in this room over to this. Now, if I switch that, now the mirror is over here and the window's over here. So when we do this, the one-way mirror reverses itself. Okay, so there's still the phenomenon. It just happens to be on the other side. So now we're thinking, okay, there's something about light difference here that's going to be important. All right, we also want to be thinking about what's going on if there was no light or if light was on in both. So I'm going to pause the video real quick and I'm going to draw our few diagrams or model. Well, yeah, diagrams and models are interchangeable. We're going to go from there. All right, so I've drawn some models. This is our original consensus model that we had, where we had the light on in room A and then not in room B. And then the teacher is able to see the student, and the student sees their own reflection. So then what I was talking about before is if the light turns on here, okay, we have the same thing. Now this person can see this one, and then this person is just seeing their reflection. Okay? So now what we have to figure out is what do you think would happen if both lights were on and or both lights were off. So that's what we looked at yesterday. I mean, you can say hi real quick, bud.
Hi.
There it is. And so now this is our discussion about what happened. So I'm just going to go through. So if you want to take a moment, I would highly recommend you take a moment, and you hit pause, and you think about and draw out. What do you think you would see with both lights on? What do you think you would see with no lights on? So pause it and do that work, because I'm going to start here now. All right, so with both lights on, what's going to happen is we're just going to, each person's going to see their reflection. Okay, so each place will be having a reflection. When there's no lights on, You don't see anything. In the classroom, we might see some stuff because of our boxes. That boundary is loose and that gets light in. And so really, if it's dark, you shouldn't really be able to see anything. Kind of what we were talking about in that mini lesson earlier. And so we need to think about what's going on with this model. What's going on with the phenomenon. And what's going on is there seems to be, we really need that difference in light. If we have a difference in light, then it's stronger. And we also need to realize that we've made a big mistake on our original consensus model. So I want you to take a moment. I want you to look at our models. And I've made the mistake on each model. And I want you to think of two things. Number one, how do we show, because this isn't a model yet. This isn't a model yet because there are no arrows. Remember, we need to have arrows in any model that we have. And remember when we say, like, if I wanted to say this is the one-way mirror, that's not really an arrow, that's a label. All right? That's a label. So that's not an arrow. This is an arrow. This is an arrow. So how do we add arrows to this diagram, this model, to make it a model? And then also, what mistake did we make in our consensus model that I have made in the other models as well? So I want you to really think about that. Pause that. Come up with an idea, and then when you're ready, find out the answer, and pause that sucker. All right, so here we go. So first off, in order to show, actually, I'm going to talk about our mistake. So what we did wrong here is the direction of our arrows. Okay, our arrows are incorrect. Why? Well, the arrow should emanate from the light, right? The light source, and it bounces off the student and then goes into the eyes of the teacher. And the other thing, the light comes off, bounces off the student, bounces off the mirror, and goes back into the student's eyes. And so our arrows were pointing in the wrong, but they have to start from the light, come down, bounce off of the things, and go into the eyes of the people. So that's called path of light. Right? That unobstructed path that goes from the light source to your eye. The way we were doing it was line of sight, which is not scientifically accurate. Now, how do we add light? How do we add arrows here? Well, what should be happening is there, see, this one's messed up. So this should be what? Light here, boom, and then right off in the eyes, down, eyes, okay. If there's no light, well, what should be happening if this light was on? There should be light coming down and coming off and coming back, right? But it's not happening. So we draw the arrow of what could be happening, but we put an X in it to show that nothing's happening. So arrow with an X. So here, our problem was those arrows need to be pointing into our eyes, and the way we show an arrow when nothing is, or show movement, show when there's not movement, is when we have an arrow and then we have an X in it. Now I want to talk about this concept of idea pirating, which I should have talked about a little bit before. So idea pirating. What is idea pirating? Idea pirating is what it sounds like. It's like pirates steal stuff. And so idea pirating is this idea that we steal someone's idea. Now, sometimes people get they get upset. Like, oh, he's cheating off me. He's copying my idea. But in science, we're working as a team and we're collaborating. And so when someone says an idea, that idea is for everyone to think about and to take if they want and to build on it. So we're always taking and building and changing. Okay, so we want like ideas to come together and combine and grow into something different. And so idea pirating is not a problem in science class. We're trying to help each other out. And so, yeah. All right, so take a moment to do your anchor, and I'm going to move on to the mini thing in 3, 2, 1. Where should the arrows be pointing in our one-way mirror phenomenon model? So where should they be pointing? Again, I'm just going to go. You need to hit pause and write your answer down. They should have been pointing towards the eye. How should we include arrows in a model where no movement is happening, like in that no light scenario? Again, pause. I'm going to say it in 3, 2, 1. We do the arrow, and then we cross it. When do we see objects? 3, 2, 1. When that light bounces, reflects off of them into our eyes on the unobstructed path. What is idea pirating? That's that idea that we steal from someone else. And then it's okay because we're working together. Bye.